Hi kids, it's Mr. Josephs. In this video, I'm going to talk to you about heat and processes. There are two main types of processes. One is an endothermic process. This is a process that requires energy to happen. And the second is an exothermic process that releases heat when they happen. Now, I like to think of these two with an analogy. So, us humans have skeletons that are inside of us. They are endoskeletons. Insects have exoskeletons. Their skeletons are on the outside. An endothermic process requires energy. Energy goes into the process. And an exothermic process releases energy. All right, so that's how I think about this. And there's another way to think about these as well a little bit. Let's look at endothermic processes and exothermic processes, both physical and chemical processes, or physical and chemical changes. So here's an example. Melting water is an endothermic process. Here's some ice. The particles are vibrating slightly, but they aren't moving around each other. Okay, so we have solid water, and to make it into liquid water, we need to add energy, heat energy, and eventually those particles will start to move around each other and they become liquid water. This is a physical change because the substance isn't changing at all. And we can see that energy is actually a reactant. Heat energy is a reactant. And that's a good indication, or that is an indication that we've got an endothermic process occurring. Let's look at an endothermic process that's a chemical change. So photosynthesis is an endothermic process as well. In a leaf, we have carbon dioxide that comes in from the environment, from the atmosphere. We also have some water that comes up through the stem and the roots. Now we're going to add some energy to this system in the form of the sunlight. This is energy coming in. It's a reactant. Then a chemical change is going to occur, and we form some glucose and some oxygen, and the oxygen goes into the environment. So that is an endothermic process, a chemical change, because bonds are being broken and new ones were being formed. So here are the two examples that I just showed you. First, a physical endothermic process, and the second is a chemical endothermic process. And in both of these cases, energy is a reactant, and that is how you recognize this as occurring. Sometimes the reactant won't just say energy, it will give you a number in joules or kilojoules per mole. So when you see numbers in a chemical equation or an equation, you will know that that is telling you about the heat energy that is required for the reaction. All right, so we've looked at endothermic processes, the processes that require energy to occur. So now let's look at exothermic processes, or processes that release thermal energy when they occur. So it should come no surprise to you that when we freeze water, we start with liquid water. If we want to change that into a solid, we take energy away, or energy is released. So heat is released into the environment, and the particles become a solid. They would be moving around a little bit more, but I didn't have the animation in this case to show that they would be doing that. So that is a physical change, the opposite of the endothermic process that we saw before. All right, let's look at a physical exothermic example. So when we have a Bunsen burner, we have natural gas, which is made up of hydrocarbons, and a great majority of that hydrocarbon is methane, and the oxygen comes up from the environment, and they undergo a combustion reaction, and they release heat energy. They also release, as we have learned before, they release carbon dioxide and water, and they go out into the environment as well. So this is an exothermic chemical reaction that occurs. So in summary, here's our two examples: our physical change, where we have solid water turning into liquid water and releasing energy in the process, and our example 2, where we have the hydrocarbon and oxygen combusting to make carbon dioxide and water and energy. And it's heat energy that's given off because, when a Bunsen burner is burning, it is very hot. And both of these processes, the important thing to see is that energy is a product. It is produced. Okay, that is our that is how we understand exothermic and endothermic processes. Now, I will mention that on the reference tables, there's a reference table I, and this reference table can tell you whether an process is or is not an exothermic or endothermic reaction. And we have this thing called heat of reaction, which we will learn in the future a little more about. But the delta H, and it says right down here at the bottom, if the delta H values are negative, this is an exothermic reaction. All right, so when you come up across a reaction that does not have any energy in it, you should go to this table, because it will be on here if I give it to you. And you look and you see it. If it's negative, it's going to be exothermic. If it's positive, it's going to be endothermic. That's as simple as that. So make sure you look. And also, you could also look at this, and if you have the reverse of a reaction, it will be the opposite of whatever you see over here. So, for example, if I have H2 plus I2 makes 2HI, it's positive 53 kilojoules per mole. However, if I have the reverse of this, which would be 2HI goes to 2I2 and H2, it would be minus 53 kilojoules per mole, and it would be exothermic in that case. And that's how you figure this out. So there's a Google form for you to complete that goes along with this video, and you should be in good state in order to finish that now. So have a good time. Bye.